Hello, in this video we're going to examine the output gap from the perspective of the supply side. We first need to recall that total output is equal to the sum of potential output plus any deviation from that potential, and we'll call that the output gap. Now we can think of this in dollars. So for example, down here we have potential output, which is $16 trillion, and then we have an output gap of $320 billion, so we can add those guys up. However, it's often convenient for us to think about the output gap as a percent of potential output, and here you can see that we've written that in lowercase. In this example, the output gap is 2% of potential output, so we calculate output as potential times 1 plus the output gap, 1 plus 2%, and we get the same number, that's 16,320 billion. Whenever we think about the supply side, we have to first think about the production function. We have to think about the factors of production, capital and labor, and we also have to think about total factor productivity. So when we think about labor, we're going to be asking certain questions. What is the size of our labor force? How productive are our workers? How educated are they? How much do we work? How much work effort do we put in? When we think about capital, we have to ask about the size of our productive capital stock. How much productive machinery, plant and equipment, or information technology have we built up? Has our economy been investing? Finally, regarding total factor productivity, we're essentially asking how efficiently are we at converting our factors of production into goods and services? Have our technological capabilities improved? We also have to think about our country's policies and our country's institutions. Are we running policies that are designed to help us produce more efficiently, or are our policies and institutions an obstacle to producing? Now we're going to consider three cases: when the output gap is equal to 0, the output gap is above 0, and the output gap is below 0. When the output gap is equal to 0, that is to say when our actual output is equal to potential output, the employment or unemployment rates of labor are at their long-run normal or natural levels. The rate of capacity utilization is at its long-run or natural rate, and total factor productivity remains at its long-run normal level. When the gap increases, the employment rate is abnormally high, or alternatively, the unemployment rate is abnormally low, as more workers than normal agree to accept a job, perhaps because wages are higher than usual, or because other options become less attractive. For example, if unemployment benefits fall. Capacity utilization rises above its long-run normal level as more equipment and vehicles are brought into use and factories run longer shifts. Or we may become more productive than usual. Perhaps, for example, weather conditions are better than normal, and that helps to bring about a more abundant harvest. What happens when actual output falls below potential? That is to say, the output gap decreases. In this case, the employment rate is abnormally low, or the unemployment rate is abnormally high, as more workers than normal choose to opt out of working, perhaps because wages are lower than usual, or other options become more attractive. For example, unemployment benefits rise. Or, if wages are rigid downward, some workers may be shut out of employment. Capacity utilization falls below its normal level as more equipment and vehicles are sidelined and factories cut some shifts. Or we may become less productive than usual. Perhaps poor weather conditions can decimate our harvest. There are some important interrelationships between total factor productivity, rates of capacity utilization, and labor employment/unemployment rates. For example, we may have an increase in total factor productivity. That's going to increase the marginal products of capital and labor. Regarding capital, more idle capacity will be taken off the sidelines and be used for production. More members of the labor force will accept employment as wages rise. In the other direction, suppose that we have a decrease in total factor productivity. That's going to reduce the marginal product of both capital and labor. More idle capacity will be sent to the sidelines and not used for productions. Fewer members of the labor force will accept employment as wages fall, and some will be shut out of employment if wages are sticky on the downside. The combined effects of these changes in total factor productivity, capacity utilization rates, and the rates of labor employment/unemployment are reflected in shocks to the short-run aggregate supply curve, what we will call a production-based shock, or PBS. So the key ideas from this video: first, that supply is determined by factors of production and total factor productivity. Secondly, that short-run fluctuations in supply correspond to the short-run changes in employment and unemployment rates and capacity utilization rates and short-run changes in productivity. And also, a shock to the short-run aggregate supply is what we call a production-based shock, is the combined effects of changes in total factor productivity, factor utilization for capital and labor. There's a detailed example in the book in Chapter 10, Part 1, that I invite you to take a look at.